How bullets are made. Satisfying manufacturing process. Have you ever held a bullet and wondered how something so small can change everything? A tiny metal cylinder, cold, silent, and perfectly engineered, capable of traveling faster than sound and striking with unbelievable precision. But before it ever reaches a weapon, before it ever hits a target, it begins its life in one of the most fascinating manufacturing processes on Earth. Today, you're not just watching a bullet being made. You're stepping inside the secret world where raw metal becomes power, where chemistry meets engineering, and where every mistake is measured in milliseconds. This is how bullets are made. The journey begins. Raw metal to perfect case. It all starts with a plain sheet of brass. Not impressive, not dangerous, just metal. But watch closely. Massive steel presses begin punching perfect circles out of the brass sheet, thousands per minute. Each tiny disc is then drawn, stretched, and shaped again and again, forming a tube that starts to look like the base of a bullet casing. In these factories, precision isn't a luxury, it's survival. A microscopic flaw can cause a misfire. A misfire can cost a life. So every casing goes through rollers, stretchers, polishers, and hardness tests until each one is perfectly smooth, perfectly uniform, and perfectly deadly. By the time it reaches the next stage, it already looks like a bullet casing, but without a primer, powder, or projectile, it's just a hollow shell waiting for purpose. The primer, where the explosion is born. Now the casing meets the component that brings it to life, the primer. The primer is the heartbeat of every round, a tiny metal cup filled with a shock-sensitive explosive compound. Workers or automated machines carefully place a dot of priming paste into the cup. It's unstable, powerful, and incredibly dangerous to handle. Then a thin metal disc is pressed on top to seal it in place. This little circle of explosive material is what ignites the entire bullet. Without it, the round is silent. With it, everything changes. The primer is pressed into the bottom of the casing. The bullet now has the spark, but still needs the fire. The powder, controlled explosion. You are now about to see something strangely satisfying. Every casing moves along a conveyor into a powder dosing station, a machine that measures the exact amount of smokeless gunpowder needed. Not too much, not too little, exactly right. Because gunpowder doesn't explode in the traditional sense. It burns fast and violently, creating gas pressure that launches the bullet forward. Each grain is engineered for consistency. Each charge is measured with surgical accuracy. The second that powder enters the casing, it stops being a harmless piece of brass and becomes a miniature pressure chamber waiting to unleash a controlled explosion. The bullet projectile, where precision meets power. Now comes the part everyone recognizes, the projectile. Copper, lead, steel, each factory may differ, but the idea is the same. A soft lead core wrapped in a harder metal jacket. The jacket is formed first. Brass or copper cups are drawn into shape, just like the casing. Hot lead is then injected, forming a core inside. Finally, the jacket is closed around the lead with astonishing force, creating a perfect aerodynamic shape. Some bullets are tipped with polymers for speed. Others are hollow-pointed for controlled expansion. And some are armor-piercing, built from hardened steel. Whatever the purpose, every bullet must be perfect, perfectly round, perfectly balanced, and perfectly calibrated to fly straight. Because once fired, A single millimeter of misalignment can change everything. The final marriage. Bullet meets brass. Here comes the most satisfying step. Casings filled with powder travel down one line, projectiles glide down another. At the final station, a high-pressure press drives each bullet into its casing with absolute precision. This process is called seating and crimping. The machine seats the bullet to the exact depth required, then crimps it tightly to ensure the round stays intact under recoil, pressure, and movement. This is the moment when everything becomes real. A casing, a primer, powder, a projectile. Together, they become a bullet. The test. No room for failure.
We test.
Before any round leaves the factory, it undergoes strict quality tests. Cartridges are weighed, measured, inspected under magnification. Some are fired in sealed test barrels, where computers analyze pressure curves in microseconds. A bad bullet doesn't get shipped, it gets scrapped. Factories don't just make ammunition, they guarantee it works every single time. Because in the real world, failure isn't an option. The end of the line and the start of the bullet's journey. Finally, the finished bullets travel down conveyors, polished until they gleam under the lights. They drop into trays, roll into boxes, and get sealed for delivery. And that's the part most people think is the end. But really, it's only the beginning. These bullets will be used at firing ranges, in law enforcement, in military operations, and in sports shooting around the world. Each one identical, each one engineered to perform. Each bullet carries a story that begins not with violence, but with machines, metal, chemistry, and precision hidden inside a tiny metal package. A bullet is simple to look at, but the process that creates it is nothing short of extraordinary.